Next up, it can be easy to focus on the crops themselves and forget how important the soil underneath is. Market Journal spoke with University of Nebraska Extension soil scientist Dr. Charles Shapiro to learn how the understanding of different properties and different types of soil is key to proper soil management.
When we talk about physical properties and even the biological and chemical properties, the physical properties are basically the foundation and the structure on which soil exists. And so texture is the foundation of that structure. So it's very fundamental. If you know the texture of the soil, you can predict a number of other qualities, how much water the soil can hold, how much organic matter the soil can maintain. And so it doesn't tell us everything, because how the soil is managed and where it is in the geography build on that texture. But texture is just like whether you have a wood house or a brick house or a sandcastle. So that's what we consider the fundamental part of the physical properties. The soil texture triangle is set up so that we can have three major categories: clay, sand, and silt. And anywhere on the triangle we can figure out the percent of clay or silt and sand. And it's a visual concept of how the different textures fit together. We have arbitrarily set up three major classes of particle size, and they have different properties, so there is logic and science behind it. But we have sand, silt, and clay. And so a soil is 100% something, and so it's going to be a certain division between sand, silt, and clay. And the triangle allows us to have everything add up to 100. And you can see when you look at the triangle, if you go from the lower left-hand side all the way up to the point or to the right, you'll see you go from sand to clay or sand to silt. And as scientists, we like to draw nice, neat lines and say, if you're 29%, you're one thing, and 30% you're another. But in reality, those lines are a lot more vague. But it gives a farmer and somebody some way of communicating. Like if you called me on the phone and you said, I have this and this problem, I'll probably say, what kind of soil do you have? And then you may or may not know. A farmer might just say it's gumbo or something, and then I have to deconstruct it. But that gives me an idea of other questions to ask. So it's the entry point. What I have actually in my hand is just a rod, and they use this actually out west. You can see there's a little ball on the end. And in the western part of the state, they use this to find where the soil moisture is, because in wheat country, and this is wheat that we're standing in, we don't have as much wheat here in the eastern part of the state, but they could go out in the field and push this down, and then when they hit dry ground, they know. And if you're going into the season and you only have this much moisture, that's a different plan than if you have a full profile. What I'm going to use it for today is not really to find out where the moisture is, but where the compacted layers are. And we're standing on the surface, and you could dig down with your trowel or something and find out what the first inch or two is, but it's really hard to get down to 2 or 3 feet. And here it goes down all the way. If we were on some area where there was wheel tracks, it would stop at a certain distance. So something like this, it doesn't have a dial. We do have ones with dials, but a practitioner could get pretty good at just using it. You have one set of strength, I have another. So when you're pushing harder. You don't know what the PSI is, but you would know that you had a oomph into it. And that'll change. If you go onto a very dry soil, it's going to have a different amount of oomph. Now, we don't really know what's causing it to stop. It could be dry soil, or it could be compacted. And then I would take a shovel or a spade and I could dig around that hole, and we can look and investigate further. Nebraskans are very lucky that they have deep soils, but if you go to another part of the country or the world, you might hit bedrock at 6 inches, in which case, you don't need a big rod like this. But, so it gives you some more information. But what we're wanting to do is find if there's a compressed layer, because if the soil's compressed, the roots won't be able to penetrate, and water may be harder to get through, and there's a cycle of bad things that happens.